Hello friends, welcome to engineering tutorial. So this is the fourth question which we are going to discuss related to diode connections. So here we have in this question two silicon diodes connected in this way, and we have a 15 volt DC voltage source and a 7 kilo ohm resistance, and it has been asked to find this voltage at the output side here. So again, like in any diode circuit which we have discussed, the first important step, the objective is to find the state of the two diodes, diode D1 and diode D2, whether they are on or off, or forward biased or reverse biased. That is the important question, because unless and until we don't find the exact state of the diode, we cannot proceed forward. So we have already discussed two methods of approaching the circuit. First, open circuiting the diodes or replacing the diodes with their equivalent circuit representation, the built-in potential, and then finding the direction of current flowing through the diode. So we'll go with the second method here. We will replace the diode with their equivalent circuit representations, assuming that they are on. Okay, so this diode D1 will be replaced with its equivalent built-in potential, which is 0.7 volt silicon. Diode D2 also the same, 0.7 volt. And then 7 kilo ohm, this is the output ground, and here we have 15 volt. Now we have to apply KVL here, and we'll find this current flowing through the two diodes. So applying KVL here, we get 15 minus 0.7 minus 0.7 minus 7 to I is equal to 0. Okay, or we can say that I is equal to 15 minus 1.4 by 7, which is equal to 15 minus 1.4, which is 13.6 by 7, which is, let me calculate, it is coming around 1.9428, or we can say it is 1.94 milliampere. Okay, it is milliampere because it is in kilo ohm, that's why it is milliampere. Now this current, it is positive, there is no negative sign here. It means that the current I is flowing through the diodes in this way, D1, D2, current is flowing in this way, which is this. Current I from P to N through both the diodes. As the current is flowing through P to N, from P to N through both the diodes, so both the diodes D1 and D2, they are on, forward biased. So both the diodes are on, so this analysis that we did just to find this current I, this is also true. So the current flowing through the circuit is 1.94 milliampere. Now it has been asked to find the voltage V0. So it is simply V0 is 7 kilo ohm into I. V0 is equal to 7 kilo ohm into this current, which is 1.94 milliampere, which is equal to, it is coming around, let me calculate, it is coming around 13.6 volt. This output voltage V0 is 13.6 volt. So this is the method we use the replacing the diode with its equivalent circuit, assuming the diode to be on. Then we find the direction of current flowing through the diode from P to N. It was positive, it was flowing from P to N, okay, P to N current was flowing, so it is on. So we use that method, and we found that the two diodes are on. Then we used the analysis technique to find the current I and then the output voltage. Okay, so this is the fourth question which we solved. So this is the fifth question related to diode connections which we are going to solve. So in this we have again a silicon diode. It has two resistances, 4.7 kilo ohm, 2.2 kilo ohm, a 10 volt DC voltage source and a -5 voltage source. And in this question we have been asked to find this current I flowing through the circuit. The voltage drops across 4.7 kilo ohm and 2.2 kilo ohm resistors, and this voltage V subscript O. So before doing all of this, again, like in any diode circuit, the important question is whether this diode is on or not. So we will be using the, assuming the diode to be on, finding the current, that approach. So we will replace the diode with its equivalent circuit, the built-in potential 0.7 volt. Then we will include the resistor 4.7 kilo ohm, then the voltage 10 volt, then this 2.2 kilo ohm, and this 5 volt. This is 5 volt, -5 volt it has been given. So that's why the negative terminal is connected first. Here it is plus 10 volt. That's why we connected the positive end. Here it is -5 volt. So it is connected to the negative end first. This is V0. Okay. And here 0 current, ampere current will flow. So this current I is the same as this I. Okay. So everything is set. Now we will put KVL in this circuit. It is 10 minus 4.7 into I. It is minus 0.7. Okay. Then minus 2.2 into I plus 5 is equal to 0. That implies I is equal to 10 minus 0.7 plus 5 divided by bringing the i's together, which is 6.9. So it is in kilo ohm, so that's why it will be milliampere. So it is 15 minus 0.7, 14.3 by 6.9 milliampere. So it will come very close to 2 something, I think. Let me calculate to get the exact value. So it is 2.07 milliampere. It is coming 2.07 milliampere. Now this 2.07 milliampere, it is positive. plus 2.07 milliampere. It means our assumption here, let me do it here, the current is flowing from P end to N end, 0.7 volt. This current is flowing from P end to N end, P to N through the diode. So if it is flowing from P to N through the diode, it means that the diode, this diode is on. Our assumption was correct. Diode is on, it is forward biased. So everything that we did with the circuit, it was true because our assumption was true. Now it has been asked to find the current I, which we got here, 2.07 milliampere. I is 2.07 milliampere. Next, it has been asked to find V1, the voltage drop across 4.7 kilo ohm. So that would be V1 is I into 4.7 kilo ohm equal to 2.07 milliampere into 4.7 kilo ohm, which is coming, let us calculate, it is coming around 9.74 volt. Similarly, V2, the voltage drop across 2.2 kilo ohm, just 2.07 into 2.2. So this is coming around 4.55 volt. 4.55 volt. So we have got V1, V2, we have got I. Next is V0. Okay, so to determine V0, let me erase all these things. Okay, so V0 is this voltage. So if we put KVL here, okay, V0 says 2.2 kilo ohm, this is 5 volt, minus 5 volt, and this is V0, this is I flowing in this way. So if we put KVL here, we'll get minus 5 plus 2.2 kilo ohm into I, which is 2.07 minus V0 is equal to 0. So V0 is equal to this. V0 will be equal to how much? It is coming minus 5 plus 4.55, which is equal to, it will be coming minus 0.45 volt. Okay, it will be coming V0 is equal to minus 0.45 volt. Okay, so we have got V0 is equal to minus 0.45 volt. So this was the entire thing. So we got I 2.07 milliampere, we have got V1 9.74 milliampere, and we have got V2 4.55 volt, and we have got V0 minus 0.45 volt. So everything was related to whether the diode is on or not. That is the important thing. Once you find out that, rest is just basic circuit analysis, calculations, all that. So here we have used assuming the diode to be on, finding the current through the diode, determining whether it is flowing from P to N. If it is that, then the diode is on. So this is the fifth question. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.